Good morning, one and all, to another edition of Finzics with Mr. Finn. This is for Thursday, March 26th, 2020. Hey guys, hope you're doing okay today. Just got a couple of things to share right off the bat. Number one, don't forget on Friday, tomorrow, we're going to have our Google Form summary event. Call it a quiz if you want to call it a quiz. I'm just calling it a summary Google form. Got a few questions on there. I think I'm going to hit each topic with just one question. So whatever you have been able to do over the last 2 weeks, I want to make sure you get some kind of validation for that, some kind of feedback other than just meeting with me for the Google Meets. So we're going to do that. And we mentioned a couple of times that we don't know what is going to happen with the rest of the school year, but as a student, you want to be prepared for the worst case scenario. And the worst case scenario is obviously you have to test out of physics so you can get credit for the class. So I'm going to operate on that respect, and if it turns out not to be that, then obviously we'll have an optional unit, and it won't be any big deal, but either way, we want to make sure we're covering our bases. Number two, I apologize to all you viewers slash listeners, a few people on the other outside of our little group here, the Comical Canadian. Want to shout out to that guy for checking in on me. Appreciate the feedback, guys. But apologizing, I was working around with some editing of the film each day, and I think I cut out some very important instructional pieces. So what I'm going to have to do is go back through my videos, see what I trimmed out. I was actually trimming out just the piece I wanted to cut out, but I trimmed out the content before that. Either way, I'm going to try to get that hooked up maybe over the break. In a couple of days, we have our spring break. So I'll try to go through that and shore up any problems we have with cutout material. Okay. So today, I want to address a question we had come through. Some people were talking about what problems or what are some of the power distributions in multiple bulb circuits. So I'm going to take a simple circuit for now. I'm going to talk it through with you, and then we'll do that exact lab scenario with our equipment here, and we'll figure out how close we are. And that should hopefully answer the question about power distribution. I'm going to use 3 bulbs in a simple series circuit. And then after the break, I'll introduce you guys into parallel circuits and we'll go from there. Okay, let's take a look at what we have here. Okay guys, we're here at the magic board here. Now let's take a look at the circuit we have with 3 bulbs. So I have a 3-volt supply, 31.5, 10.5, and 31.5. Those are my bulbs. I've got 2 long bulbs and 1 round bulb in between. Now, the first thing we have to know, oh, by the way, I also have a milliammeter. Remember, this is my multimeter, but it's calibrated to measure current. So, I've got those 3 bulbs are labeled 1, 2, and 3. I also have a pink line demonstrating or representing the current flow in the circuit. So what we're going to do here is we're going to have to make some definite decisions about power distributed to each bulb. To do this, we're also going to need to have the current. So I'm going to find the current first, and then I'm going to take the multimeter out to measure voltage for each bulb. Okay, so what do we have here? 31.5, 10.5, and 31.5. The total resistance in the circuit is therefore 73.5. If I add all those resistors up, remember this is a series circuit, so we're just going to add resistors together to get 73.5. The total voltage is 2 batteries. I'm going to assume that's right around 3 volts. That's what they're rated at. So 3 volts divided by 73.5 should give us the current in the system, which we find to be about 0.04 amps. Now, if we express that in milliamps, it's about 40 milliamps. Now, according to sig figs, we don't know if my calculator is cutting it off, but we're going to find out. It's somewhere in that 40 milliamp range. Okay, so we're going to do this as a demonstration first. and then we'll talk about the power distributed to each bulb. Okay guys, here is my setup. I have my battery pack. I've got my ammeter, and that's the first thing in the line because we're going from the yellow line into the negative of the ammeter terminal, move that off to the side, through the ammeter, out the red line, and into bulb number 1, that's a long bulb, bulb number 2, white to white there, bulb number 2, then to bulb 3 by 2 more white wires, and then back to the battery again. So when I hook it up, you can see immediately we've got light here, we've got light here, we've got very little light here, but we do have current passing through because otherwise these bulbs would not be on. And we know that because if we unscrew this bulb with no light, if we unscrew it from its holder, the bulbs just go out. So with this bulb screwed in, current is running through the system, and our current value is approximately about 47 milliamps. Okay, so that does correspond loosely with what we have in our calculation. So what we're going to do here is we're going to disconnect the multimeter from the system, and we're going to take it out. Now, here's one thing I'm going to have to show you. We're moving the input from the milliamp input over to the voltage input. And then we got to move the dial to where it says voltage. Okay, so now we're set up to read voltage. Now, remember the voltmeter hooks up outside of the system. So I'm going to plug it back in. I have my 2 bulbs lit. And so you know current is running through the system. Somewhere on the other of the 47 milliamps. Now I'm going to check the voltage for each bulb just by pressing across the bulb. Okay, I've got about 1.31 volts there. I've got about 240 millivolts there. So I'm going to write these down so I don't forget them. The first one was what now? 1.32 volts. And the last one, 1.20 volts. All right, so I'll put those on the board and we'll talk about what we have here. Okay guys, we're back. Let's summarize what we did today here. In the lab, we took 3 bulbs, stuck them in one big circuit with the milliammeter to measure current, then took the ammeter out, turned it over to voltage, and measured the applied voltage to each bulb. Let's see what we have here. My power is current times voltage. Bulb number 1, I'm using the real current that was measured from the meter now. 47 milliamps is actually 0.047 amps. We just got to move the decimal place 3 places to get from milliamps to amps. 0.047 amps times the 1.3 volts that we measured across bulb 1 by using our voltmeter, and we got 0.061 watts. Bulb number 2, that was the round bulb. 0.047 amps, because remember, they have to have the same flow throughout all 3 bulbs, times 0.24 volts, that's what we read on the voltage on that one, that was 240 millivolts, was equal to 0.011 volts. Lastly, bulb 3, P3 was 0.047 amps, times the 1.2 volts gave you about 0.056 watts. Now we could add all that power up and get a total power. Or we could take the total voltage and multiply by the total current. Total voltage is the sum of the applied voltages to each bulb. So what do we have here? 1.3 volts plus 0.24 volts plus 1.2 volts should give you 2.74 volts or 2.7 volts. Now if we multiplied 2.7 times the current 0.047 amps, we would get the total power in the entire circuit, which would also be a sum of these individual powers. Now you might be asking yourself, Mr. Finn, how come the long bulb gave a different voltage in the third position as opposed to the bulb in the first position? That's an excellent question, and we'll try to handle some of those things as we get into more episodes on circuits. But for now, let's just say that the three bulb distribution in terms of power pretty much followed what we thought we would see in terms of the bigger resistances get the bigger amounts of power, and the smaller resistances get the smaller amounts of power if they're in the same circuit together. Okay guys, thanks so much for your time today. Did you think about what that total power would have been? Did you take the total voltage and multiply by the total current? Remember, our current was 0.047 amps. And according to the magic board, and we summed up all those voltages, we got 2.7 volts. So if you multiplied 2.7 volts by 0.047 amps, and you got a value of 0.126 watts, well, you were correct. Or if you just added up those individual power values from each bulb, you would have got right around the same answer. Okay guys, that talks about the power distribution for three bulbs in a series circuit. Tomorrow we'll talk a little bit more about some of these applications with power and voltage and current in other types of circuits. But for today, remember, two big announcements. Number one, tomorrow the Google form will be online from 10 a.m. to 2 p.m. So see if you can log on and fill out that eval for me and test yourself to see how well you did. Secondly, if we think that this stretch where we don't have actual school time together is going to last longer than is originally anticipated, we're going to need you guys to keep up with the material so we can somehow find a way to test out of physics at the end of a regularly scheduled school year. Now, if we end up coming back, we can make these optional units, obviously, as originally intended. But if we don't, I want to make sure you guys have enough information to, number one, take your standardized tests if you choose to do so, or AP tests, and two, you'll be able to test out of your regular high school curriculum in terms of physics by the end of the scheduled school year in June. Anyway, guys, I'll be available for Google Meets this week. Check the doc for your times on that, okay? And we'll see you tomorrow for our last day before spring break. Have a great day, guys.